With day 4, I have some very, very important definitions to memorize. It's really important that you write these down, study them as much as you can, so this is just absolutely automatic. Okay? So definitions to memorize. Number 1, F is increasing. If F is increasing, what do we know for sure? Well, we know for sure that F prime is positive. So we know F prime is positive whenever F is increasing. So if they give us a function, F, and they want to know when is F increasing, we need to do the derivative, set it equal to 0, do our number line test to test whether F prime is plus or minus. Okay, report the interval. If we have an F prime graph, and they ask where F is increasing, we're just reporting whenever that F prime graph is above the x-axis. Okay, F is increasing, F prime is greater than 0. Therefore, when F is decreasing, we know that F prime would be less than 0. Okay? So again, if you have a function f and they ask you where it's decreasing, do the derivative, set it equal to 0, and then test on your number line to figure out plus minus regions. If they have an f prime graph, look for where that f prime graph is below the x-axis. Okay? If they give you the function f prime, you don't have to do any derivatives. You just set that function equal to 0 and figure out where it's plus or minus. Okay? That's increasing. F is increasing, F is decreasing. Obviously, it could be any letter. G would be G prime greater than 0 for G increasing. Okay, next. Critical points of F. Critical points of F, by definition, are when F prime equals 0 or when F prime is undefined. Okay. So again, if you have a function, do the derivative, set it equal to 0, or report where that derivative is undefined, right? Something could be undefined if at an x value we're dividing by 0, right? Something like that. Or we're doing the log of a square root of a negative number, something like that. Okay? Generally, it's usually just going to be when f prime is 0, but we have to be aware of f prime being undefined as well. Those are critical points of f. Another way that they ask a similar definition to critical points is when they talk about horizontal tangents. Okay? Horizontal tangents of f. Okay? A horizontal tangent of f is simply when f prime equals 0. Okay? A horizontal line has a slope of 0, so f prime must equal 0. It doesn't include the f prime as undefined. If they don't often ask about this, but if they ever ask about vertical tangents of f. A vertical tangent, the slope of a vertical line we know is undefined. So that would simply be when f prime is undefined. So that would be like when the denominator of a fraction is equal to 0. Okay. They talk a lot about critical points on the test. They sometimes talk about horizontal tangents. On a few tests, I've seen them talk about vertical tangents. Okay. Not as common, but if they ask about it, we'll be ready. Okay, The next one is a big one. Local. Another word they use for local is relative. They mean the same thing. Local or relative max. Okay. F of F. F will have a local or relative max when F prime, right, it'll be at critical points, and it's where F prime switches from positive to negative, because F is switching from increasing, right, F prime greater than 0, F is switching from increasing to decreasing. I want to talk about one more definition for local or relative maxes of F. If it's hard for us to test F prime switching plus to minus, okay, another way we can do it, if you think about a local maximum, local maximums are generally going to be concave down. So if F prime equals 0, right here, F prime would equal 0 at that max, and concave down, so F double prime is less than 0. That's another way we can prove that something is a max. I don't use that way very often, but sometimes, especially with implicit derivatives, it can be helpful to show, like, okay, I know dy dx is 0 here, and I know d squared y dx squared, I know it's negative. So that's a way that another way that you can prove a local max. Okay, but the big one is right here. F prime switches plus to minus. So again, we'll do a number line test of our F primes, and we'll, if the left side is plus and the right side is minus, then we know F prime switch from plus to minus. It's a local max. On an F prime graph, on a graph of F prime, this would be a local max, because F prime is switching from plus to minus. Okay? Next one. Local or relative min of F. Okay? Again, the big one here is F prime switches minus to plus, negative to positive. Okay? A local min also could be when F prime equals 0 and F double prime is positive. Concave up and a critical point would indicate a local min. Okay? On a graph, F prime graph, this would be our local min. Because again, F prime switches minus to plus. So we need to be able to know that definition, F prime switches minus to plus, and identify that on a graph of F prime. Almost 100% guarantee you'll have to do that. Okay. Neither point, neither max nor min of F. That is when F prime doesn't switch signs. What does that look like on an F prime graph? Well, it's a 0 that does this, right? That's a neither. F prime is plus on the left, F prime is plus on the right. That's going to look like a terrace point on the graph of F. Okay? 3 more definitions for you. Let's start with concave up. F is concave up. Concave up relates, concavity always relates to the second derivative. Concave up will be when F double prime is positive. Okay? So if you have a function and they ask you, where's this thing concave up, get to f double prime, set it equal to 0, and do your number line test. Just like for increasing and decreasing, but we're using the second derivative instead of the first derivative. But if you have a graph of f prime, it's helpful to know that f is also going to be concave up when f prime is increasing. Okay. So look for that f prime graph to be increasing. That's where f is going to be concave up. Lastly, it's helpful to know what concave up looks like on an f graph. F is smiling. That's concave up. Concave down is then the reverse of all of these. F is concave down. When f double prime is negative, when f prime is decreasing, or when f is frowning. Notice this frowning definition is only for the graph of f. F prime graph will not necessarily be frowning or smiling. F prime will be decreasing. Okay. Last one, inflection point. Oops. Inflection points of f. Okay. You're going to be very, very careful. By definition, an inflection point of f occurs when f double prime switches signs. So if you have a function, get to the second derivative, we're going to switch signs at 0, find your zeros, and test to see if f double prime actually switches from plus to minus. We need to actually switch f double prime from plus to minus at that x value. So those zeros have to be crossing the x-axis, right? We have to go from plus to minus or minus to plus to actually have an inflection point. What about on an f prime graph? Well, at an f prime graph, again, it's when we switch concavity. So it's when f prime goes from increasing to decreasing, or vice versa. Okay. And on an f graph, f goes from smiling to frowning, or vice versa. That's all of the definitions for today. These absolutely have to 100% be automatic definitions that we know every single time. And this will help us on tons and tons of problems. Multiple choice, free response, with calculator, without calculator. These definitions are crucial. Have them memorized, be able to answer that immediately. That helps you know exactly what to do. Okay, that's it for today. 2 Chains. Thanks for those who came to the optional review today. 2 Chains, bye.